Welcome to my channel Glory with Mathematics. Please subscribe, like and share.
Dear students, let us start the basic geometrical ideas part 2. Here in this section we shall discuss about polygons. So before going to polygon, first you have to know what do you mean by curves. Plane curves. When you join a number of points without lifting a pencil from the paper and without tracing any portion of the drawing other than single points, you get a plane curve. So in this figure, these are simple curve. So first one is not closed, then next one is closed. And in the next line, these are not simple curve. So these are the diagrams of some curves: straight line, circle, ellipse, polygon and parabola. These are all the examples of curves. So what do you mean by polygons? A simple closed curve made up of only line segments is called a polygons. Poly means many and gon means side. So polygons are the closed figures bounded by line segments. So these are the figures of some polygons. So classification of polygons. The polygons are classified according to the number of sides or vertices they have. So triangle is a polygon having 3 sides. So a polygon having 3 sides is known as a triangle. Quadrilateral is a polygon having 4 sides. A polygon having 5 sides is known as a pentagon. And hexagon is a polygon having 6 sides. So a polygon having 7 sides is known as a heptagon. And octagon is a polygon having 8 sides. And nonagon is a polygon having 9 sides. And decagon is a polygon having 10 sides. So with n sides, a polygon is called as n-gon. Then come to what is the diagonal of a polygon. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. So here are some polygons and the dotted lines drawn are the diagonals of these polygons. Then interior and exterior of a closed curve. The interior has a boundary but the exterior has no boundary. So in the first figure, the interior has shown by the orange color, and in the second figure, the exterior part is shown by the orange color. Thank you. Dear students, let us find the in-center of a triangle. So what do you mean by in-center? The three angle bisectors of a triangle are concurrent, or the three angle bisectors of a triangle meet at a point. That point is known as in-center. So by using the in-center, we can draw the in-circle which touches the east side of the triangle. So let us first draw a triangle. So this is our triangle ABC. We have to first draw the line segments that coincide with each side. So this is BC, this is AB, and this is AB line segment. So then we have to construct the angle bisectors of three angles. First, we have to draw the angle bisector of angle A. So this is the angle bisector of angle A. So let us color it. Then we have to draw the angle bisector of angle B. So this is the angle bisector of angle B. So let us change the color to red, so that we can easily identify which lines are the angle bisectors. Then we have to draw the angle bisector of angle C. So then change the color as red. So these are the three angle bisectors. They meet at a point. Let this point is D, and D is known as the in-center of the triangle ABC. So whatever may be the triangle, that may be acute triangle or obtuse triangle or right triangle, D is known as the in-center. So let us find the in-center for a right triangle. So this is the D is the in-center where ABC is a right angle triangle. And if ABC is a obtuse angle triangle and this is the in-center D. All the three angle bisectors meet at D and D is the in-center. So let us draw the in-circle by using the in-center. So D is the center, in-center of the triangle ABC. Then what is the radius? The distance from in-center to each side are equal. That means the perpendicular distance. So we have to draw the perpendicular line from D to each side. So we have to draw the perpendicular line to each side. So this is the perpendicular line. So let's change the color. Then another perpendicular line from D to AB. Then another perpendicular line from D to BC. Yes, we have done the three perpendicular lines. So let this point is . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . This is E. This is F. And this is G. That means DE perpendicular to BC. DF perpendicular to AB. And DG perpendicular to BC. So by taking D as center and DE, DF and DG as radius, we have to draw a circle. So by taking D as center, we have to draw the circle. So here this is the green color circle is known as the in center. So we can draw the in circle for right triangle also. So this is the in center for a right triangle. And this is the in center of an obtuse angle triangle. So in this way we can use GeoGebra app to find or to draw many figures in geometry or in mathematics. Here we will prove the angle sum property of a triangle. We know that the angle sum property of a triangle is the sum of three angles of a triangle is 180 degree. So let us do it by an activity through GeoGebra resources. This is another method to prove the angle sum property of a triangle. Let us prove sum of odd numbers. So first sum of first one odd number is 1. So if n is equal to 2, then this is 4. Then if n is equal to 3, then this is 9. N is equal to 3, then this is 9. Then if n is equal to 4, n is equal to 4, then this is 16. Then if n is equal to 5, then this is 25. Then n is equal to 6, this is 36. Then n is equal to 7, this is 49. Then n is equal to 8. The sum is 64. Sum of first 8 odd numbers, 64. Then n is equal to 9. The sum of 9 odd numbers is 81. Like this. So n is equal to 10. So sum of first 10 odd numbers is 100. Then n is 11. This is 121. So like this, it is proved that the sum of first n odd numbers is n square. Let us prove the Pythagoras theorem by this activity through GeoGebra resources. So here the magenta colored figures are the right triangles. All are congruent right triangles having the smaller side as A unit, another side is B unit, and the hypotenuse is C unit. The four triangles are arranged to form a square. So this square is having dimension A plus B. So by the arrangement of the four triangles, a blank space is formed by the yellow colored square. So the area of the blank space is C square because its dimension is C unit. That is the hypotenuse of the right triangle. So if we will rearrange the four right triangles like this, so the new arrangement will be like this. So this is also the same square having dimension A plus B unit, what we have got in the previous one. So this is a square having dimension A plus B unit. Here also the same four right triangles are used. So the blank spaces are two squares. The yellow colored squares are the blank spaces. So there are two squares. So the sum of their areas is A square plus B square. So this is equal to the blank space formed by our previous arrangement. That is here, that is C square. So here we prove that C square is equal to A square plus B square. So the Pythagoras theorem is proved. So let us find the formula for surface area of a cylinder. So this is a cylinder having height h unit and radius r unit. We have to find the formula for surface area of this cylinder. So first we have to remove the two surfaces like this. The two circular bases are removed. So then we cut the cylinder along its height. So it becomes a rectangular sheet. So now we can find the surface area. First, curved surface area of the cylinder is equal to the area of this rectangular shape. So area of this rectangle is length into breadth. So the length of the rectangular sheet is equal to 2 pi r and breadth is h. So the curved surface area of the cylinder is 2 pi r h. So if we have to find the total surface area, then curved surface area plus area of two circular bases. So that is 2 pi r h plus pi r square plus pi r square. So in this way we can find the formula for curved surface area and total surface area of a cylinder. So the cylinder may be of any height and any radius, the formula will be same. So like this, the height can be minimized, the radius can be also minimized, height can be increased or decreased like this. The formula will be same. So in this way we can find the formula for curved surface area and total surface area of a cylinder. Let us find the formula for area of a parallelogram by using OLAP. So first we have to draw a parallelogram. So this is a parallelogram ABCD. So here we have to draw a perpendicular from A to CD by using a set square. So this is our set square. So in this way we have to draw perpendicular AE. AE perpendicular to CD. Then we have to cut the portion, the triangle AED from this parallelogram. Then we have to take this portion to the other side of the parallelogram and paste. So here we got a rectangle ABE'. So whose base is 3 centimeter. As the point E, C, E dash are lies on the same line, so E, C, E dash are collinear. Then what is the height? This is the height as line AE is perpendicular to ECE dash. So AE is parallel to BE dash and AE is equal to BE dash. AB is parallel to EE dash and AB is equal to EE dash. So ABEE dash is a rectangle. So here we know that the area of the parallelogram ABCD is equal to area of the rectangle ABE dash E. So what is the area of the rectangle ABE dash E? That is E dash E into AE. That is equal to base into height. The base, the E dash E is the base of the parallelogram ABCD and AE is equal to the height of the parallelogram ABCD. So in this way we derive the area formula for parallelogram is base into height. Thank you.
Dear students, let us find the formula for volume of a right circular cylinder by using online labs by Amrita University. So volume of a right circular cylinder. So here the objective is to give a suggestive demonstration of the formula for the volume of a right circular cylinder in terms of its height and radius. So here this is the figure of a right circular cylinder of height h unit and base radius is r unit. So definition of a right circular cylinder is a three-dimensional object with two congruent circles as parallel bases and a lateral surface consisting of a rectangle. So prerequisite knowledge: formula for circumference of circle is 2 pi r. Formula for volume of cuboid is length into breadth into height, that is L into B into H. Then area of a circle is pi r square. Let us do this activity. So first we have to draw a cylinder. So this is a right circular cylinder of base radius 15 unit and height is 30 unit. So then we have to cut this cylinder into 8 sectorial parts like this. The right circular cylinder was cut into 8 sectorial part. Then we have to color each sectorial part. So all the sectorial parts are colored in different colors. Then the cut pieces should be apart from each other like this. These are separated. Then we will arrange the 8 sectorial parts to form a cuboid like this. All the sectorial parts should be arranged like this to form a cuboid. So here this is the cuboid having length L, breadth B and height H. The sectorial parts join to form a solid cuboid of height H, breadth R and length pi r, because the base circumference is 2 pi r and the length of this cuboid is pi r, because the whole circumference is divided into 2 halves and the breadth of this cuboid is radius of the base. So the volume of the cylinder is equal to the volume of this cuboid, that is length into breadth into height. So pi r into r into h. So that is pi r square h. So here by this experiment we proved that the volume of the cylinder is pi r square h.
I am using Google Forms. After completion of each topic, I am giving a question form in Google Form like this. This is the sample of a class 8 revision test. So these are the responses. I am using Khan Academy to give assignments to my students. Already I have enrolled the students from class 6, 8, 9 and 10 students in Khan Academy. Every day I am giving assignment to them and they are doing the assignment, then automatically their progress and their scores come to me. So this is the way how I am giving assignments to each class. All the students are appearing the assignments. So this is the assignment for class 10. This is the assignment for class 8.